Imagine the world's fastest cars going silent. No roaring V12 engines, no crackling exhausts, just instant electric thrust. Supercars are changing faster than ever, shifting from petrol engines to hybrid and full electric power. Today, we explore how supercar engines are evolving, why the change is happening, and what the future of performance looks like. 1. The golden age of petrol supercars. For over 100 years, the supercar world has been dominated by internal combustion engines. These engines defined sound, emotion, driving connection, heroic engineering, mechanical drama. From Ferrari's screaming V8s to Lamborghini's howling V12s, petrol engines delivered an experience that went beyond numbers. They built character, gave cars personality, made supercars feel alive. A petrol engine is not just a power source, it is a beating heart. The feeling of pistons firing, valves opening, and exhaust gases exploding is a symphony that defines automotive passion. For decades, the formula didn't change. Bigger engine plus more cylinders equals more power. But the world around supercars began shifting. Rules tightened, emissions dropped, technology advanced, and the industry entered a new era. The petrol engine would not disappear overnight, but it would evolve. 2. The turning point. Why change was necessary. There were several reasons why supercar manufacturers had to rethink the traditional petrol engine. A. Strict global emission regulations. Governments worldwide introduced CO2 limits, noise restrictions, efficiency standards, environmental penalties. Large displacement engines became harder to justify. B. Fuel efficiency expectations. Even supercar owners began demanding better mileage, lower emissions, reduced fuel costs. C. Advancements in electric motors. Electric technology suddenly offered instant torque, zero lag, no gears, high efficiency. The performance world started paying attention. D. Competition. Pressure. Tesla and other EV performance brands proved that electric power could beat supercars in acceleration. Traditional brands had to respond. These forces pushed the industry toward a major evolution. 3. Downsizing. The first stage of transformation. The earliest step in the transition came around the 2000s. Manufacturers began reducing engine size, adding turbocharging, using advanced fuel injection. Examples include Ferrari switching from naturally aspirated V8s to turbocharged V8s, Lamborghini exploring smaller engines in future platforms, McLaren committing early to twin-turbo technology. This phase delivered big benefits: higher torque, lower emissions, better fuel economy, powerful but efficient engines. But some fans felt something was lost. The sound changed, the response changed, the experience changed. Supercars were adapting, but they were not done evolving. 4. Hybrid power, the new supercar formula. The second major transformation was the arrival of hybrid technology. Supercars began combining petrol engines, electric motors, high-capacity batteries. Why? Because hybrids offered the perfect technical blend. A. Electric instant torque. Electric motors eliminate turbo lag and provide immediate acceleration. B. Cleaner operation. Hybrids lowered CO2, fuel use, urban emissions. C. Better efficiency under laws. Brands could meet stringent environmental regulations without sacrificing performance. D. Performance beyond petrol alone. Hybrid hypercars shocked the world with new levels of power. Porsche 918, Spider McLaren, P1, Ferrari, LaFerrari. These cars proved something. Electric power was not the enemy of performance, it could enhance it. Soon, nearly every major supercar brand followed. Ferrari launched hybrid, V6 and V8 powertrains. Lamborghini introduced electric-assisted V12 systems. McLaren put hybrid systems into production models. The hybrid era became the new standard. 5. The rise of full electric supercars. The next stage is fully electric supercars. No petrol engine at all. Electric supercars deliver advantages that petrol engines cannot. A. Instant maximum torque. Electric motors produce full torque from 0 RPM. Acceleration becomes explosive. B. No gear changes. Single-speed systems mean seamless power delivery, no shift interruption, maximum traction. C. Smooth power control. Electric vehicles allow precise torque vectoring, independent wheel control, better stability in corners. D. Extreme simplicity? No. Pistons, valves, gearboxes, fuel systems, just electric motors and battery. Electric supercars already exist. Rimac Nevera, Pininfarina, Battista, Lotus Evija, Tesla, Roadster, upcoming. And they are fast, record-breaking fast. The Rimac Nevera became the world's fastest accelerating production car, proving the electric future is not slow. 6. Battery technology, the real key. The biggest challenge in electric supercars is not the motor, it is the battery. Batteries must balance. Weight, cooling range, degradation, charge time. Supercar engineers are working on A. Solid-state batteries. These could improve. 7. Sound. From noise to digital emotion. One of the biggest cultural changes is sound. Petrol engines create mechanical vibration, exhaust explosions, sonic personality. Electric cars are nearly silent. Manufacturers are exploring solutions. Digital sound design, simulated exhaust frequencies, cabin vibration feedback systems. For example, Porsche is experimenting with synthetic sound signatures. Some brands are creating unique digital identities, like musical engines. Future laws may regulate electric vehicle sound for pedestrian awareness. The emotional experience is changing, not disappearing. 8. Aerodynamics is becoming more important than displacement. As supercar power moves toward electrons, aerodynamic performance becomes a tool for efficiency, a way to increase range, a method to cool batteries, a way to generate downforce. Future supercar engineering focuses on smart air channels, movable aero elements, low-drag surfaces, battery cooling paths, internal airflow instead of external vents. Power matters, yet efficiency is becoming a new part of the performance equation. 9. The role of software and AI in future supercars. Electric power allows computers to take greater control in real time. AI systems can predict tire grip, adjust torque per wheel, control traction better than humans, optimize battery use, manage temperature dynamically. Performance tuning becomes digital. Driving modes could evolve from normal sport track to drift AI mode, launch control prediction mode, adaptive racing intelligence. Supercars are becoming smarter, not just faster. 10. Will petrol engines disappear? Many enthusiasts fear the end of the petrol supercar era, but reality may look different. Some brands will continue small volume production using synthetic fuels, biofuels, hydrogen combustion. Future petrol engines may survive in limited production hypercars, collector cars, track specials. The emotional combustion engine may shrink, but it will not vanish overnight. For the next decade, we will likely see hybrid supercars dominating electric hypercars, expanding limited petrol icons, still existing. The supercar world now has multiple paths. 11. The future? What comes next? Tomorrow's supercars could include A. Lightweight electric sports cars with instant torque and 700 plus kilometers range. B. Hydrogen combustion engines, zero emissions but traditional sound and emotion. C. Solid-state powered hypercars, fast charging, lighter weight, and massive power. D. AI-assisted performance systems, a car that learns the driver. The definition of a supercar is evolving. Not just horsepower, not just cylinders, not just top speed, but how the car delivers emotion, performance, and technology together. Conclusion. Supercar engines have traveled an incredible journey, from giant petrol, V12 engines, to compact turbo engines, to hybrid combinations and now full electric power. The evolution is not the end of performance. It is a new chapter. The supercar of the future may not roar, but it will still thrill, excite, and redefine what speed means in the next generation. Like, share, and subscribe for more.